Hello, this week in geology we are going to be learning all about mass wasting, and our lab this week is to learn to identify mass wasting hazards as more than just landslides or earth movements. So what we're going to be doing is using particle shape and size to and how it moves to categorize mass wasting events, and then to start to learn a little bit about some of the future risk of mass wasting, which helps us better prepare so that when they do happen, it's less of an impact, and we can also better figure out what we need to do to get rid of the problem. So I am looking at this in a PDF version, but there is both a PDF and a Word version depending on your preference for completing the lab this week. Now, when you're going through the lab, there is a lot of background information about how we classify mass wasting materials. Consolidated materials are those that stay together as more or less a single solid mass, and it moves downslope as one piece. So we call this material rock. Unconsolidated materials are things that are not attached together, and when they move chaotically, and we then categorize them based on their size. If it's very large, so things from boulders to cobbles, think fist sides, or bigger, and also small things, we call it debris. If it's more in the sand size to silt size particles with some clay size particles in there, we call it earth. And if it's really fine, we call it mud. So this would be that silt to clay size sediment particle. Okay, and then how things move. They can fall through air. They can slide along an existing smooth inclined plane. They can occur on a rotating curved plane. That makes it a slump. If it is unconsolidated material that just moves down slope on top of other stuff, everything's moving independently, we call it a flow. And then if we start to look at it and we see that it's just the upper surface of the material moving, not the whole surface, we would call it creep. Okay, and creep is very, very slow. We can tell that it's moving because of tilted fence posts, power lines, curved tree trunks. Basically anything sitting in that upper layer starts to move as that upper layer goes through its freeze-thaw cycle and moves down slope. So what you're going to do throughout this activity is make some interpretations using the different photographs in Appendix E. So to help you understand mass wasting events and how we categorize it, as well as the speed, you can use this first image. And then what you're going to do is look at each of the pictures as it asks you to in the lab, and you're going to try to identify things that you see. I highly recommend printing this out if you don't have the paper lab manual and circling things, identifying what you see. You know, in this image here, we see these very large talus slopes. If you look on it, it has, I'll try to let you see right in here, this boulder is definitely big. So these green things, whoops, over here are small trees, and so think about how big the trees are on the other side of this lake. Okay, we have very steep slopes and mountains, and all of this is going to help you try to identify what happened to create all of this material right here. So what you'll be doing is going through and trying to figure out how to classify the material, then like what type of material is moving, then how we identify the event, use both the name of the material that moves and how it's moving, and then explain your evidence. I definitely encourage you to try to identify it on these pictures. If you absolutely cannot do that, you can type your answers in detail with what you did to determine your classification. That will be fine. So you'll be going through each of these slides. When you're trying to figure out the differences between earth and mud, earth tends to be a little bit more yellow in color because it often contains more quartz particles that are not teeny tiny. Debris, again, look for boulders. Rock, look for large solid masses that possibly explode and become smaller once they impact. And then again, mud is going to look a little bit darker brown in color to black, okay, and not have any big particles in it. All right, in exercise 2, you are going to be looking specifically at the Slumgillian slide that happened in Colorado. And to do that, you're going to be looking at a topographic map that is included. It starts kind of through this area. This is actually just showing some identifications. We have the Slumgillian Creek. We have the blockage that happened above. And we can see that this is the scarp or the head of the material that moved, and we can see that the material flowed downwards, had this nice big toe, and it actually created, and it flowed out in this direction as well, and it blocked movement of the water trying to come downstream. Okay, we can actually see it actually extends even farther down here, but it flowed back, and then this also flowed again, so another big toe. This is inactive toe, and this is the active toe. And this is Lake San Cristobal, which it also blocked, created a blockage in the valley so water couldn't flow through, and the water then pooled up. And in the map view, we can see that here again. So this is where it's coming down. It's a little bit more zoomed in. We can see the little bit of the toe kind of going into the other valley here, but continuing down, and then the toe extends back around this way. Okay, so you are going to be making some interpretations off of this. You will be determining that contour elevation of locations B and Z. Use the center point in that diagram. You are going to be tracing the boundaries of the slide, identifying where the head or the top of the flow occurred, and then you're going to be trying to make some interpretations based off of the lake and how it formed. And I highly recommend when you're trying to look at these is to remember your rules of V's about contours, to read the elevations above and below to try to figure out where it's higher and lower, and just remember that streams flow from high to low. Okay, the area in red here shows a location where we had another high risk. When we're looking on a topographic map for places that are high risk for having mass wasting events, we look for a place where the contour lines bow in opposite directions. So I'm going to zoom in a little bit. We'll say 150. Okay. And if you look right here, this contour line wraps back uphill, and this contour line, which comes out of the red, bows outwards downhill. So this spot right here is a flat open surface that will accumulate some water and is likely to flow downwards as a possible event. This is also another location. So when you're going through the map, you're going to look for places where the contours bow apart as possible future slides or future events. Okay, so you look at both sides of the map, try to identify 3, and just do your best on that part of the activity. And that gets you all the way to the end. It shouldn't be too difficult. If you have any questions, please post them in the I Need Help discussion. But with that, you're ready to go. I wish you luck and happy learning.